In this tutorial I want to revisit two tools. Firstly, the construction options, where Mike has used the CATIA presets to build his car. And that specifies the G0, G1 and G2 continuity tolerances for building surfaces. And the second tool I want to work with is the surface continuity checker here on the Evaluate palette. And this can be used to check if those G0, G1 and G2 tolerances have been achieved between the surface patches. So I'll check for curvature now, and I can simply click on the boundaries. And where I get a green locator, it's within tolerance, and where it's yellow, then it's failed. And the letter tells me that it's failed positional continuity. But I need more information than that, so I can use my middle mouse button to get a cone plot of the deviation. And in this case, it's just a single brown spike showing here where the problem is. And I can use the right-hand mouse key to get a report on all the measurements at that point. So it's only very slightly outside the 0.001 tolerance setting, which is why the designers let it go through. Now it might be that we want more detailed information than that. So one technique that many people use is to go into the construction options and create a new set of tolerances by choosing one of the presets, say, doing a copy, and then just renaming it. So let's call that tighter toles, for example. And this is now my own customizable set. So I can now reduce that G0 tolerance by a factor of 10. So that would mean that when I apply the continuity check, then it fails, but it now shows much more detail in the cone plot, as it's now measuring to that tighter tolerance. And I can see much more clearly the nature of the problem. And the right-hand key will still give me the same numeric information. Now those tolerances are too tight to try to build at, so I'll go back to CATIA V5 for building, and just keep those tighter tolerances for checking or for problem solving. Now when I use the surface continuity checker, it's useful to set it to just the continuity level that you want to check. So I'll use positional to check along this chamfer line that's got no blending or fillet yet. And the reason for setting it only to position is that I get a very clear pass or fail result. So here and here I can see that it's failing positional continuity, and I don't get spurious tangent or curvature measures that I don't need. So if I want to check for tangency, then I'd set it to tangent, and here I'd expect it to pass and it's fine. But it's also quite useful to use that tangent continuity check on this sharp positional edge, because the cone plot gives us useful information about the consistency of the angular relationship between the surfaces. And this one's looking nice and consistent. But if I try along these other edges, I'm getting a much more varied result. And you notice here that I'm getting a mixture of information. So there's positional information in the cone plot and some tangent information too. So if I want to clarify that, we can create another custom set of tolerances. And this one I'm just going to call check tangent only. And here I'm going to set the gap distance to really quite coarse, so 0.1 of a millimeter, so that nothing should fail that. And that's useful because when I now check for tangency, it's not reporting any positional errors, so I can focus more easily on the tangency issues. Now if I want to be able to properly compare these edges, then the cone plots need to be the same scale. And I can adjust them interactively with the first mouse button. But if I want to be accurate, then if I use the information window with the locator selected, then I get all sorts of useful information. And down here at the bottom I get the cone scale. So I could make that -50, for example. And then if I choose this next locator, I can make that 50, and then this one too. And that means I've now got a consistent cone plot, and I can see how that angle is changing as it flows through the surfaces. So along these two edges is fine, but then on this curve here it's going a bit extreme, so that's something I may want to fix. So I'll make sure my construction options are back to CATIA V5. And the information window is really useful if you want to get very detailed with your evaluation. So if I do a positional continuity check here, and I get a failure, and then use my middle mouse button to show the cone, then if I open up the information window, Then up here we can change the continuity that it's checking for. And you can also change the way that it's checking the spacing. So it's defaulted to per span. And if I just reduce this checkpoints value to 1, then you'll see what it's doing. So these are both single span surfaces on this A-pillar. So here it's checking once. And if I switch that to 2, then it's checking twice, or 3, etc. So that's what you're changing when you're using your middle mouse button. You're changing the number of checkpoints. So typically we just drag the mouse until we've got the confidence that we're catching all of the errors. If you want to check by arc length, then the checking is per millimetre. So that's every 1 millimetre, and that's every 10 millimetres, every 20 millimetres, etc. And again, the middle mouse button will do that interactively. And you can also change the tolerance that it's checking to in the information window. So it takes it from the construction options to start with, but I could change that to a looser value, and then of course it passes, or to a tighter value. So that's an alternative to creating your own different tolerance sets. So between these three tools, the surface continuity check, the construction options, and the information window, you've got complete control over how you're checking continuity on the surface boundaries.